processing 100 samples a day manually is just an absolute waste of time. Being able to automate that really helps the lab do more with less, but also help redeploy that scientist to do other more important things that are tailored towards what they're specialized in.
Welcome to another episode of the Omni Pod, where we're enabling conversations between life science thought leaders to help you get the most out of your preclinical research.
Today we're talking about why expensive instruments struggle when the front end is manual and how automating tissue prep brings consistency, protects data, and gives labs the reliability they need.
I'm Bill Schick, Fractional CMO, and today I'm again speaking with Gabby Ryan, Senior Applications Specialist at Omni. Hey, Gabby.
Hey, Bill. Nice to be here.
Today's topic is trying to do 2026 science with 2016 tech.
We hit the nail on the head there with that little phrase, 2026 science with 2016 tech. Really resonates with me, at least in my experience as an application scientist working for a company that sells laboratory equipment, especially laboratory equipment that funnels into what happens to a sample from pre-extraction, pre-data acquisition. So anything sample prep. So cat's out of the bag. We sell sample homogenizers at Omni, and a lot of times from that field perspective and working with customers and supporting them and helping them develop their assays and optimize sample lysis, I always see, most of the time, I don't like to make blanket statements, but most of the time I see customers doing really groundbreaking science on the back end. They've got, the latest and greatest sequencers. They're looking for this super cool biomarker that's going to help funnel into drug development. And, we go in the lab and we see a lot of times it's one of two things. We either see a largely manual method. So we've got, scientists working with manual homogenizers, so rotor-stator based homogenizers, or even sometimes more remedial than that with mortar and pestle homogenizers, or they've got what I like to call, and we like to call it Omni, the bead mill graveyard. So they've got a lineup of old and homogenizers that have broken that are lined up on the bench, and the least robust part of the workflow is most oftentimes what I see is the front end part. And so the customers will come to us, scientists will come to us, they're like, this isn't working, and they get to the point where there's a last straw that breaks the camel's back, whether it's the lab is sick and tired of having to redo samples, they finally narrowed it down to their sample homogenization, or they just are scaling up and they know that manual mortar and pestle or handheld one sample at a time, rotor-stator is not going to cut it. And there's like this imbalance, right, between the front end tech and the downstream tech is like way up here and the front end tech is way down here. So that's a lot of times the context that we see a customer come to us. And again, from that field-based perspective of working with customers to help them optimize their front end and optimize their sample lysis, that's a lot of times what I see from a sort of a broad sweeping perspective at a high level is really there's a gap between the front end and the downstream tech. So
yeah, in some of the things that we've seen and worked on together, it does seem that in these cases, there's a perspective, if you will, that I can just throw bodies at it, and that process was good enough for me when I was starting out, or this is not a critical area to invest in because it's doable.
Right.
Through a manual process. And so that's not the place to be looking at. But what are some of the issues that you see that are that can show up as a result of some of this kind of inconsistent manual processing?
Yeah, I mean, it's really all over the board. I think primarily the first thing that we see is just the data quality downstream sometimes won't pass QC, or they'll have, in 96 samples, 10 of them will, the data on the back end, whether it's DNA, RNA, or protein, they're not getting enough protein, they're not getting enough DNA or RNA, or what they are getting is poor quality. A lot of times too, we'll see, so because of that, right, walking that through all the way, through the whole process, if a sample doesn't pass QC, a lot of times it has to go back. They have to reprocess it or pull, because a lot of times these labs, they'll get a sample in and they'll split it in two. So they'll have one half of the sample unprocessed that goes into a freezer and the other half gets processed. And the reason for that is in the event of a rerun that has to happen. And a lot of times we see that typically being the bottleneck or the pain point that will drive the customer to us, or they realize that in scaling up, the act of scaling up or post scale up, if the sample lysis and the sample preparation isn't brought up to that downstream level, then it becomes to a point where either the data quality on the back end is so poor, or the lab is just sick and tired, and they really it shines a light on the front end prep when a lab will scale up, and they'll sort of, like, you can blink a light and it's like, okay, wow, sample prep is the bottleneck. And so that will drive the lab to come to Omni or seek out sample homogenizers that are more efficient, more effective than what they have. So number one, data quality. Number two, I think a lab that has scaled up, that has an optimizer sample prep, once they do so, it becomes very evident that the sample lysis is subpar and they need to focus on that aspect. And I think those are really the two main big ones that we see when it comes to that, again, that mismatch and the cues that can point a lab to, hey, sample prep is not good, not where it needs to be.
And some of the things that we talked about before would be, sometimes having, multiple people manually doing sample prep. There's inconsistency, or there are, inadvertently mistakes made. What are some examples of that?
Yeah, and I think with manual, it really is like there's a dictionary of things that can go wrong. I think number one, when you have, like, let's walk through this. You have a scientist at the bench with a handheld homogenizer. So they're holding this homogenizer in their hand and manually chasing a sample around a tube with their hand, with their arm. So it's a very manual process, not as manual as mortar and pestle, but still very much hands-on and can be grueling, right? If you compound that, I would say more than 10 samples a day, you get into territory where arms become tired, scientists become bored, and no matter how hard we try to make each sample the same and process the same, when you've got a homogenizer that's largely reliant on, again, the scientist chasing that tube, or chasing the probe around in the sample tube, fatigue can be an issue when you're compounding that across. I mean, these labs are processing hundreds of samples a day at times, even 50. I mean, I like to say 10 is usually the cutoff for me when it comes to manually processing, but you'd be surprised what these labs are able to, like you said, throw warm bodies at it, and it makes it a little better, right? But then when you get the direction to scale up again, it points a finger right at the sample prep. So I think number one is fatigue and the inability of a manual homogenizer, like a rotor-stator homogenizer or even mortar and pestle, to complete the same task of sample lysis and treat every sample the same, versus something like a bead mill or something that's programmable where you can have every sample treated exactly the same. We're not relying on the scientist to work the sample the same way each time, times 96 or times 100 samples a day. It really is just glaring when it comes to the manual side of things, and how when you realize that there is the human error involved when processing the sample and being able to repeat that identically across all samples, it really is something that I think no scientist should be responsible for. And if we could semi-automate or fully automate every single sample lysis workflow, at least in the heavy hitting, high throughput areas, I think we would be golden, right? But we don't live in a perfect world, so.
Yeah, and I think through some of the conversations that I've had with scientists, and that this is a process that's been done for hundreds of years.
Yep.
And we know it. We've gone through it. Why would you focus on changing that now? What are some of the things that are happening now that are maybe kind of pushing us out of manual processes that have worked for hundreds of years? Like, what's happening right now?
Yeah, and I think before hitting on that, I think you touched on something there too, Bill. It's the perception, and I think you also hit on that with the previous question. The perception around sample prep is really, in my opinion, not where it needs to be. Granted, I'm biased, as we sell sample homogenizers to labs, but the perception of sample prep that we see is, it's just sample prep. I don't need to worry about it. I have my techs, they grind up the samples and they get put into the, the DNA, RNA extraction, protein extraction. They get put on the liquid handler. That's the part I care about, right? As a scientist or as a lab, that's oftentimes what we see labs focusing on. So it's the perception and really the attitude around sample prep. Like you said, it's been the same way for all of these years. There's all of these papers cited, all of these protocols cited with less than robust or less than up to par homogenization methods that really don't fit the tune of today. And so leading back into your question, what's happening today that's forcing labs to focus on sample prep? I would say, we're at an age where as the years move forward, we're getting more information, more knowledge, more research is being done to understand diseases and find drug therapies and mechanisms of drugs that we haven't used before. And really, we're at like a cutting edge every single year of new technologies and new drug development mechanisms being developed and more being understood about cancer or about a rare disease that hasn't been understood before. And so I think really that pressure it's a good pressure, right? Because the more we understand, the more we can develop these new therapies to help, treat people that are sick. And that's really the pressure, because what goes into, I'm saying it in a sense and it sounds, that can't be too bad, right? But these processes from, bench research and in a university or an academic setting, or even at a pharma company, it starts in the research phase. We understand, we do things. And then at each point between the research phase and the drug being released, onto the market, it like infinitely scales up even more. So you get to the point where, we've got our Pfizers, our Regenerons that are processing literally thousands of samples a week. In the case of Regeneron, I think they run, somewhere on the order of magnitude of 1,000 samples a week, which is absolutely insane to wrap your head around, let alone to think that they're using anything except an automated homogenizer. God forbid, I can't imagine how long it would take a lab scientist to process that many samples, or scientists, even if you gathered 100 of them, right? That's still like 100 samples each, and that's a tall ask. So I really think the driving factors there are, number one, I think the amount of science and research that we understand now, and the ability we're able to put that and tailor that towards new drug therapies is really pushing forward that drug development process and making it not easier, but I think more accessible. And so we've got a lot more labs that are interested in, hey, sample prep isn't working. We're scaling up. We're doing hundreds of samples a day. We need to fix it,
Yeah, that makes perfect sense. I do think we are being pressured to do more with less.
Correct.
And so you have maybe fewer bodies in there to accomplish more. And if you are tying up a scientist on something like grinding away at a sample, that is not the best application of resources.
Yeah, I agree there, especially, scientists we're well educated. We go through, I speak for myself too, we go through hours and hours and weeks and years in labs, and we have these amazing skill sets, and to dwindle those skill sets down, like you said, to that same scientist sitting down at the bench processing 100 samples a day manually is just an absolute waste of time, no matter how you cut it. And being able to automate that, even semi-automated, like in the case of a bead mill, really helps, again, help the lab maybe do more with less, because they're making a process more efficient, but also help redeploy that scientist to do other more important things that are tailored towards what they're specialized in, because grinding up a sample at the bench manually is certainly not what we all went to school for, right?
You talked a little bit ago about some mistakes maybe, and you talked about fatigue. We've talked about some different kinds of mistakes, like almost operator error. So things like, sample cross-contamination, where you might be using one probe, if you will, and you drag one sample into another. What are, talk about that a little bit. What are some of the other manual issues that might arise, or mistakes? And even the best intentioned of us sometimes make a mistake. Talk a little bit about that.
Yeah, that's another great area. So, in the case, again, we're going back to the rotor-stator homogenizer, because that's oftentimes an area where we see stainless steel probes or stainless steel accessories that are plugged into that handheld drive unit that will spin at a designated RPM, and that performs the homogenization. I like to call them blenders on a stick, because it's literally what it is. It's like your kitchen emulsion blender. So imagine per sample, right? You can't drag the emulsion blender, if you will, into each sample. You have to take that thing apart, clean it, make sure all of the analyte, make sure all of the sample material, if you're working with something potentially pathogenic, you got to get rid of all of those materials that can potentially risk the next sample in being contaminated from the previous. And so you can, because a lab isn't going to purchase hundreds and hundreds of thousands of stainless steel generator probes. That would be a complete waste of money. And so they've got to take apart each probe, clean each probe. And so that can really pose a risk when it comes to a more manual workflow, where if a scientist doesn't clean the probe all the way, or maybe haphazardly cleans the probe, because there's all of these samples down the line that have to get processed, and time is ticking, right? And it takes a long time to process and clean. So that can definitely be another area, just like the arm fatigue and manually processing the samples, where we see, customers seeing cross-contamination because they do have to take apart these stainless steel and non-disposable, I think is the key there, accessories that are plugging into their single sample homogenizers in order to make sure that stainless steel accessory is suitable and clean and free of any residual analyte or whatever it is that the customer is concerned about for the next sample. So you can imagine walking through the time it takes to process one sample, let alone weigh the sample, get the buffer in the tubes, process the sample, and then after using a stainless steel accessory, you got to take the accessory apart, clean it, and then run the next sample, multiplied by 90, 100 samples a day or more. You can sort of see, and I painted the picture of the potential areas where things can go wrong. And so that's another great area, is definitely cleaning those stainless steel accessories, something that we see all the time.
Yeah. So of those things, like time, variability, contamination, rework, which of those things do you think is most impactful for most labs?
I think at the end of the day, it comes down to the data quality. So aside from the fact of if you are, so I think there's two important things. Number one, the data quality. Number two, that kind of feeds into data quality is, and I'm going to use the example of a DNA or RNA extraction. If, let's say the extraction is failing because the sample wasn't processed all the way. Those things that happen downstream, because the assay gets, I think, infinitely more expensive as you go downstream, because you're dealing with more expensive reagents, you're dealing with more specific reagents, like sequencing reagents or DNA and RNA extraction reagents. There's more things that come into play. And so the expense of a mistake becomes higher. And either, number one, seeing a failed extraction of an analyte, or in turn having that failed extracted analyte go into a downstream quantification or detection step where either the detection is negative, where they don't see any of what they need to see, or there's events of cross-contamination. I think those are the two things in my head, which really it's one thing. The data quality is number one. But what feeds into that data quality, I think, are the most expensive and significant errors that can occur in the lab. Because at the end of the day, that's the goal for the lab, is not just to process the sample, perform the extraction, it's to get the data point, right? And to do that successfully. So when that data point becomes questionable or doesn't pass QC, that is like perks the ears up. What is going wrong? Let's look at every single thing that happened upstream and figure out where the error is and where we need to optimize.
Yeah, and is sample prep really the area that labs start with when they're trying to figure out where the problem is?
Yeah, so I'm going to go back to a conversation I had with a customer last year at some point, and doing a DNA and RNA extraction, realizing that the PCR downstream wasn't where it needed to be. They were getting false negatives, and I think for a lab, and it's really subjective, but I think for a lab doing any kind of analyte extraction, they're probably going to look at that first, in the sense of, or in the case of like a DNA or RNA extraction, nucleic acid extraction, they're going to look at what's going into that extraction. Am I having a buffer that's not dispensed? If it's an automated extraction, are all the washes happening? Is the alcohol clean? Are any of the reagents old or expired? And so I think it's like a case of walking backwards from the data point backwards to eventually you get to sample prep. But I think because of that perception of sample prep is, it's just sample prep, I don't need to worry about that. I don't think labs focus on that. At least most labs. There are some labs that I see where they come to us and they're like, I noticed the sample wasn't homogenized all the way, and My data quality downstream wasn't the best, and I think it's because of that, right? And so you've got the labs that are cued into sample prep, and they know that it matters because they've seen the data, change between pre-optimization and post-optimization of sample prep. But I largely think labs will not necessarily look at sample prep first, and I think it's really centered around that perception of it's just sample prep, the age-old, I'm just going to follow the protocol and it does what it needs to do, right?
Right, but I mean, It sounds like a lot of time it can miss the mark, and it sounds like it can be very expensive to work your way back to troubleshoot where the problem is, because you're going through all of those steps before the step that you're maybe taking for granted isn't quite the right way to phrase that, but you're sort of looking at that as a very simple part of the process, which is incredibly impactful.
Yeah, I agree. And it really comes down to, like troubleshooting, from my head, it really comes down to like what you know, and you don't know what you don't know. I know that sounds kind of remedial, but when it comes to troubleshooting, if you've gone through troubleshooting before and kind of the areas that are common that go wrong, that can affect or produce the error or poor data quality downstream or whatever the indicator is for needing to go back and optimize something. I think it really comes down to again, what because each lab is specific to the downstream and the type of assays that they do, and so each assay kind of has their troubleshooting guide for the potential areas that can go wrong and what to do if those things do go wrong. But again, I think sample prep is generally not the first cue, but it's sometimes not all the time is it sample prep. Sometimes like it's the case of ordering a new reagent, this reagent was expired, or maybe the scientist didn't mix things correctly, and make the right recipe for a master mix or what have you. But sample prep can be that marker where if it's not going right in the first step, everything else downstream just kind of falls off the wheels fall off the bus, if you will.
So you're definitely an advocate for sample prep automation.
Yeah, for sure. Automation or even semi-automation, really just getting a lab to have an instrument that will, no matter what, every single time will process your samples the same way, all of them. In the case of like our Bead Ruptor Elite, for example, I would consider that semi-automation because, you still have to put the buffer in the tubes, weigh the samples, load them in the tubes, that sort of thing, place everything onto the tube carriage. But in the case of the 2 mil tube carriage, we can process 24 samples at a time. And so all 24 samples in that Bead Ruptor, at the protocol you put in the instrument, 4 meters per second for 30 seconds. Every single sample is going to get 4 meters per second for 30 seconds, no matter how tired the lab scientist is, right? Because the process is semi-automated and the instrument is doing the work for you. And so I think that is really the key, either semi-automated or fully automated in the case of like an Omni, like the LH96, our automated homogenizer workstation, where it's really focused on those high throughput labs, those drug development labs, pharma labs, anybody doing preclinical work where they're processing hundreds and hundreds, thousands of samples a week. And you need an instrument that's going to help you weigh, help you dilute, move tubes to sample rack with a gripper, process them in an automated fashion, and then also reformat them completely hands off, walk away. And, there's a scale, right, between semi-automated and automated, but I think a lot of labs kind of start there with that the semi-automated solution. They have that interim scale up, and then they're able to kind of, if they do, right, if they scale up even more and require automated homogenization, it's there. But I think, semi-automation is really beneficial to most labs.
Well, thank you again for joining me today. It's great talking to you.
Yeah, it was great talking to you too, Bill. Thanks.